Okay, now that we've had a discussion about basic hemodynamic principles in the cardiovascular system, I want to show you the practical application of how Ohm's law fits the hydraulic system. Remember, for the cardiovascular system, Ohm's law says that the pressure is equal to the flow times the resistance, the flow being the cardiac output. So I want to give you a little demonstration. This is a little pump with a one-way valve in it, so it will simulate the left ventricle. So fluid can only go in one way, and as I squeeze the pump, out the other way. So first I'm going to prime the pump by filling with this water and food coloring, and as I increase, you can see every time I pump, I can generate enough pressure from the muscle itself, or from the pump itself, to increase the outflow by a certain degree. Okay? No matter how much I pump, I can't really generate enough pressure to get that column of fluid very high. Okay, now I'm going to add to this pump something that simulates the aorta. Remember, the aorta is a big elastic tube, and now I have this highly compliant tube with a lot of elastance. So as I pump, you can see that no matter how high I try, I can't get the column of fluid very, very far. Now, if this is the aorta, the flow is going downstream into narrower and narrower vessels until I get to the resistance vessels of about 100 micron or so. Now I'm going to increase the peripheral resistance by adding a narrow tube. So if I add this narrow tube to the aorta, which is the arterioles in real life, and I put this on so it stays really tight, and I prime the pump again, now you can see what happens. I can get all wet, and I can drive the flow down to smaller and smaller vessels so that the tissues are adequately perfused at a high pressure head once more.